Thank you, Leonid. Welcome also from my side. My name is Sonja Wächter. I'm working now almost 11 years for Continental here in Ingolstadt in the technology department, where we're doing several physical analyses to improve and ensure the quality of our products. And we are active in research and development topics, and also participating in different research projects, also in the GaiaX project. And here in the PLC project, we created one use case, and I would like to give you a short overview about this use case, as well as the motivation behind it. And I try to explain that in this illustration. So with our use case, we represent several GaiaX interfaces across the entire product lifecycle, starting with a data set from our sensor production. We take process data from a critical manufacturing step. I will explain this step later. From a sensor out of our Continental product portfolio. And we create various communication interfaces along the product lifecycle, and therefore also valuable usability for this selected data set. So starting with the system manufacturer, who can draw performance conclusions from the process data and thus optimize the machines. The special feature here is the direct networking and combination of the system manufacturer skills with the skills of the manufacturing company, in this case Continental. And on the other hand, the service through the system manufacturer can be improved and designed to be more flexible, faster, and also targeted. For the company, the advantage is, of course, less waste, thanks to the optimized processes. Furthermore, predictive maintenance methods can be implemented through targeted data analysis, and the systems can be maintained more in line with the direct needs. This means less system downtime and less wear and tear components. So we have a higher performance and also a higher sustainability. Another idea is to create a kind of marketplace in which real process data, so this selected data from our production, of course prepared in a standardized way, is offered for further use, e.g. for training of AI models or anything else. Here we can create an interface to research and development and create a common data space that can be used in a variety of ways. And at the end of the product lifecycle, we have, of course, an interface also to the OEMs and customer. The process data can be used by the OEMs, for example, in case of complaints, to view the manufacturing process as part of the root cause analysis. And also long-term scenarios are possible for the end user, for example, in which a performance prediction of the sensor in operational mode can be made based on the original process data. And this is just there are just a few ideas. I think the potential behind this idea is much higher, and we will see that in the further work out of this use case. So now let's go to the specific use case. In the following slides, I will explain why we choose these process data and why these data that we have selected are so important. Let's start with the product portfolio from Continental. Continental is a global automotive supplier, and in the business area autonomous mobility, driver assistance systems and the sensors required for these functions are manufactured. And here we can see an overview of the sensor categories and where they are installed in the vehicle. So there are different camera sensors, radar sensors for long and short range, also surround radar. We have an ultrasonic sensor, LiDAR sensor, and an assisted automated driver control unit. And this is a sensor we use in our use case. So this ADCU provides a safe, multifunctional and central processing platform that is perfect for application in the area of high automated driving. This is achieved by integrating selected hardware and software to monitor the movement of the vehicle and control its routing states during runtime. And in addition, the ADCU runs an environmental model based on the incoming signals from the vehicle on board monitoring sensors, as well as additional information. Based on this, the ADCU route planning algorithm determines the optimal route in terms of the environmental safety and comfort and coordinates the numerous actors, e.g. brake, suspension, and so on. Yeah, and this ADCU is crucial for enabling future automated and, of course, safe driving. The graphic shows that the ADCU is represented at every step on the way to high automated driving. And that's also a reason why we select this sensor in our use case. So now I will give you an overview about the production processes. A large number of the sensors I've shown are manufactured at the location Ingolstadt. Ingolstadt is the lead plant for driver assistance system. That means that all newly developed sensors will be brought to serious production in Ingolstadt for the first time. And the production is divided in two areas, in the front-end production and in the back-end production. And in the front-end production, the electronic circuit system is manufactured. It is a process that is largely standardized for all types of circuit boards. So the circuit board are fitted with the electronic components. And in this production steps, a circuit panel made up of 2 to 10 circuit boards is printed with solder paste. That's the first step, the solder paste printing. And to do this, a stencil is placed over the panel, and the solder paste is only applied to the recesses where the components are then later assembled. The components are treated on reel and are picked up using pipettes and placed on the printed circuit board. And then the panel goes in an oven where the solder hardens and fix the components to the PCB and also create the electrical connection. So here you can see also some pictures to get a better impression. On the left side, the first step is the solder paste printing, the stances and the lay over the PCB panel and the solder that is spread over the stencil. And then we can see a pipette that is picking a component and place it then on the PCB. Here below, this is an automatic picking process. And then we are coming to the backend process. In the backend production, this is the connection of the assembled circuit boards from the front end production. And this is connected with the sensor housing, the plugs, the connectors, if necessary, other functional components such as lenses or shielding plates. And therefore, several different processes and connection technologies are used. I've listed some of them here: gluing, seeing, underfilling, then different other connection processes like laser welding, crimping, riveting, and of course screwing. We used for our use, or we selected for our use cases, screwing process. I will explain that later. The screwing process, is one of the critical process, because on one hand the process ensures that the sensor is sufficiently sealed and thus protected against external influences, and on the other hand a faulty process can cause chips to be generated and particles to be introduced into the sensor, and that can trigger, for example, shortcuts. And also to the backend process, they are included also the test stations in which the performance of the partial manufactured sensors and the final sensors are checked. This means that the manufacturing sensors are to 100% tested, and it is ensured that no faulty sensors are delivered to the customer. Now we are coming to our selected ADCU unit. Here we can see an exploded view of the sensors. So here in the middle we have our circuit board that is also already applied with components, and this will be connected with a plug and closed in a housing. We have two housing parts, so the housing and the cover, and this is closed up with a sealing and over these several screws. And we selected this screwing process for our use case. This is an important process step. I already said that, and why it is now so important. So it's first of all important for the product quality, because the tightness of the sensor influences the service life, so the performance lifetime of the sensor. And on the other hand, particles that could be generated by the screwing process can influence also the sensor performance and generate shortcuts and failures. And on the other hand, the process is also important for the sustainability, because this is the last step in the final assembly. So after we fix the screws, the sensor can no longer be dismantled, and therefore if we have an error in this screwing process, the whole fully produced sensor has to be scrapped. So that's why this process is so important and also so interesting for many areas over the whole product life cycle. I hope I can could make clear why we have decided for this process. And now I give over to Leonid again. He will explain what exactly we already did with the process data from this screwing process. At the end, we would like to thank you for your attention and your interest. I hope you've enjoyed our presentation. Yeah, and we are looking forward to continuing to successfully design our use case in the GAIA-X PLC project together. Thank you.